Alright, we're talking about solving linear inequalities here, and when we look at that, we're solving linear inequalities. We're looking at we go through a process similar to the ones we use with a linear equation, with the addition property of equality and multiplication property of equality. You know, we can pretend that inequality sign is an equal sign. And what we do to one side, we have to do to the other, essentially. So let's take an example here, and let's say we have x plus 4 is greater than or equal to 1. Well, we can think of this, and again, I'm going to say think of, as x plus 4 is equal to 1. Sure, we know we're just thinking this. If we do that, we subtract 3 from each side, we get x is equal to -2. So if we take the same principle up here, we subtract 4 from each side, we get x is greater than or equal to -3. And why is that -2 there? Change that to -3. So x is greater than or equal to -3, meaning anything greater than or equal to -3 will make this a satisfactory equation. -3 plus 4 is 1. Well, that's equal to 1. How do we put this on a number line? We have a number line here, and we know it's greater than or equal to -3. So we'll start down to -5, -4, -3, -2, -1, 0. So x is greater than or equal to -3. Well, that's inclusive, and it's greater than, so we know we're going to be moving to the right. We use brackets because it's inclusive. Put the arrow going to the right, and in interval notation, what we would have, the lowest value we can have is -3 here. So we would have a bracket with -3, comma, and then infinity with a parentheses at the end, and there's our interval notation for this. If we have a non-zero real number, meaning we can get to a situation, basically I want to get into negatives. If we ever have to divide by a negative number in an inequality, we have to flip the sign. Let's see, to illustrate this, let's say we have an inequality that's obviously true here. Say we have 6 is less than 8, okay? Well, we know we can multiply both sides by 2, and we get 12 is less than 16. That's still correct. So what if we multiply by a negative number? Now we're going to get, if we multiply both of these by -1, we're going to get -6 is less than, -8. And that's not true. -6 is greater than -8. So by multiplying by -1 makes this a false statement. The only way to make this a true statement is to change that sign. So whenever we multiply or divide by a negative number in doing linear inequality or solving them, we have to change the sign. So let's look at a sample here, an example. Let's say we have -2x less than 6. Well, to get x by itself, we have to divide both sides by -2, and if we do that, we get x, and over here we get -3. Well, we have to change the sign on that. X has to be greater than -3, because remember, our original is 2x is less than 6. So if x was greater than -3, well, -3 here times -2 would be 6. That doesn't give us a true statement, so it has to be greater than. So if we had -2, -2 times -2 is 4. Is that less than 6? Well, yeah. What about 3? Okay, well, 3 times -2 is -6. That's less than 6. So what we can see here is when we get that negative number in, we really have to look at switching that sign and being careful with that. So if we want to put this on a number line, we're saying x is really greater than -3. -2, -1, 0, 1, 2. Well, we would have greater than -3. We'd look at having parentheses here because it's not inclusive. we'll be going that way. Interval notation will be in parentheses -3 and then infinity. So the big thing here is if we multiply or divide by a negative number, we really have to change that sign. Alright, we'll do one more before we end this video, just to make sure we get it. So we'll do a little more. One is a little longer here. Let's see, 2 times x minus 3 minus 5 is less than or equal to 3 times x plus 2. Let's see what happens here when we do this. Okay, so first we want to distribute 2x. 2 times x is 2x, 2 times -3 is -6, minus 5, less than or equal to, again, we're going to distribute 3x plus 6. Okay, so now we can combine terms. 2x, -6 minus 5 is -11, less than or equal to 3x plus 6. So let's take 3x away from both sides. We get -x minus 11, less than or equal to 6. Add 11 to both sides. We get -x is less than or equal to 17. So at this point we're saying, okay, -x is less than or equal to 17. However, we want positive x. So if we multiply everything by -1, we get x is greater than or equal to -17. And if we want to put this on a number line, so to speak, then we'll look at having a number line here. We'll have -20, 19, 18, 17, -16, so on and so forth. X is greater than or equal to -17, so it's inclusive because of that equal. We'll go that way. Interval notation, we bracket, -17, comma, positive infinity parentheses. So I hope this helps a little bit with solving linear inequalities. Remember that big negative, and the negative means flip the sign. Don't forget that. That's if we're multiplying and dividing by a negative number to get x positive. So hopefully this helps with some linear inequalities. I will see you in the next video.